My name is Frank, and I work on machine learning. Today we're going to go over a few things. What is machine learning? How does machine learning work? Talk about some of the ways to use machine learning, software engineering behind machine learning, some of the equipment that we use, and how we actually go into dealing with machine learning, building it out, the results and the accuracy, and at the end, the final result. Okay, so let's get into a little bit more about what machine learning is. Machine learning is a search for a pattern or sets of patterns from a given set of training data. And this is used by different types of algorithms like Bayesian or a neural network. For the purpose of this video, we're going to use natural language processing to show how machine learning works and use this particular use case to help derive different sentences and corpus from the data. As I mentioned, that I had 4 different projects, and for the purpose of this video, I'm only going to use natural language processing. We're going to go ahead and get started with a screen share looking at how natural language processing works. So here is just a front-end element to the natural language processing I built. It's pretty cool. I like the way I've made this. So this is a GUI for the front end. Over here, I can run a model. I can export the pre-trained data. I can export the trained data. I can view some of the optimization, the performance. These things are built into the code that you can view the front end, which is wonderful. So now you can really get a sense of how the code is being built. Okay, so to go into a sense of how we built the corpus, I go into detail here about what's the corpus, how we chose our model. We use the Bayesian model right now. That is the model choice. That is kind of what we're doing here. We're focusing on the Bayesian. Why? Because if we use a neural network, it's too broad. I mentioned this before. Using a neural network is too big. I don't have that kind of size of corpus. Now, a neural network would be perfect. I've used it in Python. I'm going to train data, validating data, testing data, the metrics, computing, and everything related to that. So that's kind of what we do in there. So this is kind of what built so far. This is, again, one type of machine learning that I've worked on. Now, we get into some of the code. I built this back in 2017 initially. I said file new 2017 in December. I wanted to build this. I actually even have a video back when I was making this. Like I said, I mentioned I used the Bayesian classification for natural language processing in this. That's the best model for this particular type of modeling. It's a classification modeling, which is good because it helps predict the high probability of what intent you're trying to make. And that's the whole purpose for this. It's like, what is the highest probability of an event, or in this case, of an intent that's going to occur. Now, we'll get into metrics and performance later on, talking about how do we really perform on our core data set versus our training set versus our validation set and everything like that. So here are some properties you can see here. All these properties have gone down, showing these are all the properties that are pertaining to this particular set of data. It's a lot. Here's a lot of training, like I said, validation, testing components are built into this as well. And then, of course, saving these objects into a JSON file so that we can keep this data stored. So I use this quasi kind of thing done inside of our machine learning is I'll retrieve the data from the database. So I have a MySQL database that has all the corpus data in there and also user data. So what happens is the user would make some statement, some comment, whatever they'll do, and that would lead to determining the type of intent that the person had made, and that would be stored. So then that would be used a part of the corpus moving forward. So kind of like it's kind of self-feeding itself continuously. Now, it's kind of hard unless you have a core corpus that's working properly to help distinguish the correct intent ID. But, we're still working on that. I use this one here. I process the data. Then I do the train distribution. I save it, say the intent model, and then return a message. That's pretty much it. Now, I'll look into this here. Now, I started up. This here is actually distributing the data and its percentages, looking at exactly what percent. So initially, I want my data to be 60% in the training set, 20% in validation, and 20% in testing. Come down and I choose an n-grams. This is, if you're dealing with natural language processing, you'll understand the n-grams component. This is also using word2vec, because if you're using word2vec, you understand how words are connected to each other. 2-3 words together can have a meaning of some sort, and if you traverse through, you'll be able to say, okay, it's a high probability that these certain words mean these list of words next to it. So I could have 50 words based on this one word, because the sort of meaning by probability, and if you put two words together, the probability of all these other words come before or afterwards. It helps with meaning. So I like 2 grams. 2 grams are very useful, but when the corpus is small, it throws things off a little bit. So I try to do these kind of gram size algorithm to kind of figure out what's the best to use. So what I've done so far is to put a 1 and 2 gram, both of them, into the algorithm now because of the size of the database. I put both of them in. So I go through 1 gram, and I also choose 2 gram to help go through both. So anyway, so now this goes into the whole Bayesian components. Turning into the vectorizing the bag of words, going through all of that, and I go through and vectorize the bag of words. It's just all this is processing, and then I come in and I distribute. So this is the training, the distribution vectorization, I call it. I know big words, and I come in here and I actually, if we're going to train it, and I want to test it by each epoch, I have this set of code right here that goes through and. Let me show you this right here. It goes in this section here and tests and train a simulation I showed you earlier based on each sentence and batch size. So here's the corpus, right? The validation corpus that I mentioned. I'm gonna run a test on a certain batch size. So right now I can say the batch size is 100, but it might be too much. The batch size could also be 20 or 10 or whatever the size may be. If the index is greater than it, we'll break it. And we'll just go ahead and keep adding in and find a performance on that particular side of the batch. So if we come back here, all right, so we'll see here I'm talking about. So when I want to know how to optimize my code, I'll show you here. So it took like 1 second. So here's, I'm not feeling well, right? The response by is sad. I'm sorry to hear that. Do you want to talk about it? I'm not feeling well. It's the best I could come up with that for the time being. So, but it's going through initializing the corpus. It's finished initializing and started the decoding the text, and comes through these different parts here. It's tokenization. It's starting the next token. It's starting entity recognition, and then it's entity recognition, but starting the result retrieval. And here's entity retrieval and then starting probability distribution. Basically, here's my distribution of all my probabilities. What's the highest probability it's going to be? And then come here and it's going to end the probability distribution, start the bubbling sort, kind of figure out, okay, what's the top one, and then start packaging and then delivery. So this took about 1 second. I'm trying to get to 0.4. I'm sure I run this again. It's actually 0.24. So it's a hit or miss, really depending on the time it takes. The processing memories is pretty much the same every time. It's not, it varies just a very little bit. The only memory I typically use is just loading from the database. Loading from the JSON file, and pretty much that's, it's pretty quick. It's like 0.12 seconds. It's not really a hard thing. That's pretty quick, so I'm pretty happy with that. All right, so here is the epochs. I was talking about the epochs. So for example, for a batch size of 25, my first epoch is like 0% accurate, 80%. So it got better. So the model got better as it went forward. It actually got pretty good, not pretty good, but got much better at the 12th epoch, but then it got down. So it had a little more data, and then it couldn't technically determine it as much. So right now, it's at 28% accuracy. That's not where I want to be. I want to be at least 85%, which means which means I need to go in here and change this up a little bit. I need to put in more data, like I said, breath versus depth, as best as I can. Okay, so here is the run model. This is the actual place where the user or whomever may run the model. And in this, I would load a model from the JSON file I mentioned. So there's a lot of different ways this can be done. There's like TensorFlow has their own complete setup, closed box, how they store these things, and it's different than what I may have to do it. The way I do it personally is I store it in a JSON file. It's fast, it's quick, it's accessible. So I have here, I merge these all into certain words. Then I go through and find the entities of this. And then afterwards, I get the results based on this. And there's a lot of details. I'm not going to show it exactly yet. And then in here, we go through the corpus, get the based on intent ID that was found based on high probability. I would get the result from that, and then I will set the last bits of packaging on there, and then you get the result. Total categories 311. That means there's total 311 intents on here, and you can see the training data. This is the training data that I have so far. All right, so we're gonna go over an example of how to actually write something into the actual intent. So I'm gonna go in here, write an intent, and afterwards show you the result from that. Pretty simple. Type in here, what time is it? There, automatically it tells you the time. This is a question as a test, so high probability is what time is it? As it's told here, has probability if this is the case, and so it's 2:22 p.m. So that's what time it is right now. The reason why that it has high probability from what I discussed before is basically ranking it based on the corpus that we have here. Now, how does it know the actual time? It's a function call that we use. So I have a function for that specific intent to actually derive the time. As part of our equipment, I already have 2 additional servers, but I also have now bought a new iBuyPower server to help with fast computing. It's an i9 core processor, has a Gigabyte 2070 in it right now, as you can see, and what it does is it can compute 4,000 threads at the same time, only a few threads in a core processor. So it really helps with machine learning. When it comes to machine learning, I always make sure that I understand the problem. What are we trying to solve? I try to make sure that I get the entire picture, the data that we have, the timeline, how fast this data needs to be, how long it needs to train, the kind of model that we're using, the math behind it. I have taken Calc 1, Calc 2, Calc 3, differential equations, numerical analysis. All these things, I understand these things to help predict if the data or what we're trying to do makes sense. My name is Frisby. Thanks for listening about machine learning. Have a great day.